we are trying to achieve elbow flexion in a pronated position with no resistance, we'll be recruiting the brachialis, the brachioradialis as a prime mover between 24 and 120 degrees, and as an assist between 0 and 23 and 121 and 150. The pronator teres will also be active as an assist because of its origin and insertion on the ulna. And then we would also not be activating the biceps because then that would cause supination, and we are trying to achieve pronation. When we're doing elbow flexion with our forearm supinated and with no resistance, we're going to be recruiting the biceps brachii, and in contrast to doing it pronated with no resistance, the brachialis is now shifting to an assist because the biceps will be taking over most of the work.
That's my movement.
The brachioradialis will also be a prime mover between 24 and 120, and it'll shift to an assist between 0 and 23 and 121 and 150. Again, the pronator teres assists because of its origin and insertion on the ulna. When we're doing flexion at the elbow, whether you're in a supinated or pronated position with resistance, we'll be recruiting everything we have. So we'll be recruiting the biceps, the brachioradialis as a prime mover from 0 to 150 degrees, the brachialis, and again the pronator teres assists because of its origin and insertion in the ulna. When we're attempting to supinate, whether our elbow is fully extended or fully flexed, we'll be using our supinator and the brachioradialis to neutral. However, we will not be recruiting the biceps because it's beyond its optimal range.
So no single ladies are going to use the bicep.
When we're trying to supinate, whether the elbow is flexed to 90 degrees or throughout its range with resistance, we will be recruiting everything we need. So we'll be recruiting the supinator, the brachioradialis to neutral, and the biceps brachii because it's 4 times stronger than the supinator in elbow flex to 90 degrees. And if we're fighting resistance, we're going to want to recruit everything that can do supination.